Hi, this is the first question of the chapter 2, digits of an integer. Write a program that inputs 5-digit integers. Separate the integer with 3 spaces each. Just like this. Here is the main file. We have included the header. We have made an object. And we are gonna do this in the most of the questions of the exercises. We have included 2 functions in the public, getNumber and printNumber. And I put an integer in the private. For sure I used class. And here is the source or the file with the .cpp. Here in the sep digit, I made an integer called temp and started from 4, ended with 0, decently, decreasing the I from 4 to 0. Because I must start with 10,000 divided by the number. The number is divided by 10,000 and the remainder is taken from its division of 10 and stored in the temp. The stored number is gonna played out and with 3 spaces each. This loop is gonna still repeat itself 5 times. 2. Table. Using the techniques of this chapter, write a program that calculates the squares and the cubes of integers from 0 to 10. So, we have the square cube class. We made an object for it. We have 3 functions in the public: square, cube, and print table. We have the square cube class. We extracted the square function and we entered in. So it's gonna return the square, and here it's gonna return the cube, and here it's gonna print the table. Integer, squared, and cubed for 0 to 10. Increasing from 0 to 10, it's gonna start with 0. It's gonna start with the squared type and the cubed. This is the source, and we mention this in the header. We mentioned this in the main. Hope it's clear. Here, multiples. Write a program that reads in 2 integers and determine and prints if the first is multiple of the second. Here is the header. We have 2 functions, input numbers and check print. And we have 2 private integers, number 1 and 2. Here in the source, we input the number cn, the number 1 and the number 2. Here we will determine multiple. This is the class and we extracted checkprint from it. If 2 is a multiple of 1, then we're just gonna say the modulus operator Gonna determine if it's a multiple by giving 0 as a remainder. Here, 2 is a multiple of 1 because 2, let's say it's 2, here 4, 2 is a multiple of 4. Else if number 2 is modulus divided by 1, number 1, and the remainder is 0, then 1 is a multiple of number 2. Else the numbers are not multiples. We use in the main the inputs first and then the check first. Check second. Here, comparing integers. Write a program that asks the user to enter two integers. Obtain the number from the user, then print the larger number followed by the words is larger. If the numbers are equal, print the message these numbers are equal. So we make an object and we just use the compare function. We only have here in the class comparing integers one function and it's static compare, and we have two integers in the private. Here we're gonna use only this function compare integers. So we enter the first integer and then we enter the second integer here. So if the first is bigger than the second, then first is larger. Else if the second is bigger than the first, second is larger. And if else, cout or print these numbers are equal. It's easy. Displaying shapes. So here main, we used an object and we just took one function, print all. In the header, we only have one function, print all. And here in the source, we used IOM map, IOM man IP, or IO manipulate using namespace std. And then we have this shape. And I'm gonna just print it so you make sure. Here in the header, and we take it here from the main. We start it. Okay, I guess we have a problem. It's a problem in the PDF. Okay, there is no spaces. The problem is with the spaces. The PDF is not given a spaces. Okay, this is the answer of it. I just have to do this. Sorry for the delay. Pretty sure it's now clear. Here with the arrow, it's almost perfect. But here we have a problem. Okay, now it should work. Okay, we just have to make another definition, another editing in this shapes, but it's pretty clear. It's well. Here, account class, chapter 2. I will edit this and send the PDF with the link in the YouTube differently. This may take time. Here, create an account that a bank might use to present customers. Bank account include a data member of type and represent data balance. Provide a constructor that receives an initial balance. Use it to initialize the data member. Constructor should validate the initial balance to ensure that it's greater than or equal to 0. So if it's not, set the balance to 0 and display an error message that the balance was invalid, and we will set it to 0. Provide 3 member functions. Member functions credit should add an amount to the current balance. Member function debit should withdraw, and the balance should be left unchanged, and the function should print a message indicating debit amount exceeded account balance. Okay, let's see the code. Okay, I'm gonna try it because it will take time to explain the code. Okay, I will explain the code now. Here, in the public, we have a constructor just as you asked, and the initial balance. Here, we have a credit and debit, and get balance, and we have an integer, and we have a double in the private that's named balance to help with the get. So the get is double, just like the integer. We get the source or the implementation of the code of the function in the header. Okay, I'm sorry. I'm gonna fix this. I guess now it's fixed. So let's start the code. Oh, I'm sorry. I just have to name it header. Okay, now it's perfect. Oh, okay. 20. Yeah, now it will work. It's all because of the PDF. It's changing. Let's go to the main. And here we're gonna make a negative number. Let's say negative 50. So initial balance is invalid, setting balance to 0. Now it's 0. So when the debit amount exceed the debit, the second balance is gonna be 100 and the other one is gonna add just 13. That's the debit. That's after the credit and the debit. So the credit is 50 and here it's 100 in the second account. And here the debit is 20, just like we saw. And here the account 2, the debit is 200. So if I just added 100 to the second account, here, I'm pretty sure it's gonna be 300 because we will add 200 to it. Okay, because it's less than the credit, let's make it 150 and it's gonna be 350. Okay, it just took the debit. We're gonna be less than the credit, 50. Yes, here it is. It's less than the credit, it's gonna give it. If it's more, it's not gonna give it. Here in the header file, or in the source, the initial balance, the balance equal initial balance, else the balance is equal to 0. That's what we saw before a minute. And here the credit, if the amount is 0, is bigger than 0, the balance is going to add the amount into it. That's the credit. The amount is here. Else, error, credit amount must be greater than 0. Here, account, debit, amount. The debit, if the amount is less than the balance, then the balance must decrease the amount of this double from the balance, or else debit amount exceeded account balance. That means you have no money to withdraw. And here in the double get balance, we just return balance. Where do we use this? I'm pretty sure we used it here. Here we take the balance. Let's edit the credit, or let's finish with this and go to the another one. Invoice class. Here is the invoice class. Create a class called invoice that a hardware store might use to represent an invoice for an item sold at the store. An invoice should include 4 data members: a part of number type string, and a part description type string, a quantity of the item being purchased type integer, how many this item is available in the store, that's an integer, and the price per item, and that's integer. Okay, we'll use numbers that contain decimal points. That's another time. Your class should have a constructor Yes, I have. That initialize the for data member. Provide a set and get functions. Yes, pretty sure I'll do. For each data member. In addition, provide a member function named getInnovenceAmount that calculates the Innovence amount, multiplies the quantity by the price per item. Okay, it multiplies the quantity by price per item, then returns the amount as an int value. Let's enough with talking, and let's try the code out. Okay, we're gonna have to edit it a little bit. That's the main. And here we have the header. And here we have the source or the implementation of the functions that are in the header. This is a lot of code. Let's start trying it. Okay, header. Pretty sure we must edit it here. Header. Now let's try it out. Events, non-const. Okay, I'm pretty sure I did a const. Where is it? Yes. Yes, here. Okay, I'm gonna edit the code just to add the const, and then I will send it in. I will send it in the file, in the Word file. And when I send the file, please take a look at this code so you can make sure that I edit it well. Okay, here, date class. Create a class called date that includes 3 pieces of information as data: month, day, and year. Your class should have a constructor with 3 parameters that use the parameters to initialize the 3 data members. For the purpose of this exercise, assume that the value provided for the year and day are correct, but ensure that the month value is in range to 1 from 1 to 12, and if isn't, set the month to 1. Provide set and get function. For each data member, provide a member function display date that displays the month, day, and year, separated forward by slashes. Like test that. Okay, I'm gonna test it. Here the main. We have the set month, display date, set month, set day, and set day 13. Okay, we're just trying here. Hit the file. That's the header and the source. Here is the source. I made it const here, so it's not gonna make the same error that happened there in the last code. Here I'm gonna type the header, and here also. Okay, now we have the dates, just like this. Let's edit it. Let's say that the date here, let's put the month to 13. Now it'll just set it to 1. Here, set day to 5. Just like we see here. So, let's demonstrate class dates capabilities. Okay. Let's go to the source here and see it. We have the set month, month to M, else M to 1. Here, the get is gonna have return month, and we are gonna use this get just there. Okay, here the employee class, this one. We created a class called employee, and we have all the informations that he asked for, and we also have get, set, and get functions for each data member. Okay, if the month salary is not positive, set it to 0. Write a test program that, okay, we're gonna test it right now. Then give each employee a 10% raise and display each employee year's salary again. Okay, it's easy. Let's see it. This is the employee main file. I'm gonna edit them because this PDF made a little bit mistakes in the code. Just like this. When I edit them, I'm pretty sure you can see, here. I'm pretty sure when you check them, they are gonna be alright. Okay, we have another. Oh, I'm sorry. I didn't change this. Okay. Oh, I didn't change any of it. That's why. Here, the source. We're just gonna change it to header to work with us. This header. And now, we're gonna check it. So, the employee's one yearly salary is 24, and with the interest is gonna be 26 and 400. 26,000 for sure and 600. And the employee's year salary is 36, and here is with interest. So if I added the salary here and make it, I'm gonna edit it and make it a negative number. It's just gonna set to 0, and the interest is gonna just give it 0. Pretty sure it's fine. Here I use the const, and here I use this because when taking the constructor here, that's the constructor here, we have a string with this first name. This is too important. And here we have another string. And here we have this. So it's gonna be a pointer string. because the pointers in the memory in the computer, it can has names, it can has characters. So if we're gonna make it public, we're gonna use this. Okay, first name we have and the last name, and here set month salary, month salary. That's it. Okay, pretty sure here it is. We have four datas, two strings and two integers. Oh, I'm sorry, two strings and one integer, three datas. Here get the first name, set the first name, get the last name, set the last name, get the month and monthly salary. Here set the monthly salary and then get the year salary, give a raise, and that's it. Here, first name is just gonna be equal to this first name here. This one is gonna be this. That one. This. When I say this, here. When I say this, it just let you know which first name it's pointing to. Monthly salary. Okay, let's go to the main. Yearly salary. Give a raise, give a raise. Get yearly salary. Okay. Here it's the yearly monthly salary here. Okay, I put the monthly salary and it just gave me the yearly salary with the raise. So this is the yearly salary after I just did the monthly salary here, and this is with the raise. And I just made the raise right here. Raise amount is equal to monthly salary multiply percentage, the one here that I gave it, here the percentage here is 10. So if I just made 13%, it's just gonna have a lot more interest. Let's check it with the same monthly salary and see who's gonna take a bigger raise. Pretty sure the first one get a better raise. It's gonna add a crazy number. It's just gonna have the double. Okay, it's just had the double plus the number. So 24 plus 48 is equal to this. This is the triple. This is the double. That's what give it double 48. Yes, pretty sure this code is so clear. The others that had some errors, I'm gonna edit them so they can be this clear. Okay, target heart rate calculator. It's here from making a difference. So create a class called heart rates. Class attributes should include the first person, the person's first name, last name, date of birth, and it's gonna use set and get functions to also include a function get age that takes the age in years. Function get maximum heart rate that calculates and returns the person's maximum heart rate, and functions get heart rate that calculates and returns the person's target heart rate. Since you don't know how to obtain the current date from the computer, function get age would write an application that promotes information instantly of an object of class heart rate and print the information from that object. Okay, let's enough with talking and let's try the code out. So Let's start with the header. This is the header. This is the private databases. Here we have two strings, first name and last name, just as he asked, birth month, birthday, and birth year. So in the public functions, we have a constructor that has four databases, two strings and two integers, three integers, five. Okay, it's five, two, here three. Okay, set first name, so we get the first name string here. We're gonna use this for sure. And here, get first name, set last name, set birth months, get birth month, get and set and get. That's it. Okay, enough with talking. Let's try the code out. Okay, we have an issue here. So I am just gonna copy it here. Include that here. Source CPP. Okay. Oh, I'm sorry. This is not the source. This is the header. Pretty confused. Oh my god, the source is so long. I'm just gonna have a quick summary for it. Okay, here we just have the CMath. We're gonna use it for the heart rates, and we have, okay, we just did everything, use namespace. Okay, we took them, we put them in the private integers, and now we set them. Okay, so string first, we get it into the integer, here first name, first name, that's it, and then returns the first name with the get, set, get, set, get, set, get. Okay, it's the same, just we put it inside the private, this one, birth month, we just put it in the private. Also, this is just can do it with all these sets, so I can just delete them, but I just made them to make use for the constructor. So here the heart rate class, we get it, we extracted get age. So here, please enter the month, enter the current day, enter the current year. So age equal the current year minus the birth year. Okay, we just calculated his age. Right now, if the current, okay, age minus, it's just minus 1. Okay. This is just basic math. And here, maximum heart rates. Here we get into the real stuff. Age equals get age. This function that we did here. Yes, pretty sure it is. Then maximum heart rate is 220 minus the age, and then return the max heart rate. Get maximum. Okay, we get it. I'm pretty sure we get it. Okay, get target heart rate. So the target heart rate is max heart rate. Okay, that we just get it from the get max heart rate. This one. Okay, and the target minimum and maximum. The minimum is round. Okay, is round. This round, we get it. Okay, let's just start this already. Oh, the same issue. Okay, header. Header. Another time. Okay, we just rounded this number, max heart rates, multiply half, multiply almost 3/4. That's standard for the max heart rates. And then target heart rate is target minimum minus target maximum. Here in the main, we get into the real stuff. Maximum heart rate per second. Okay, we just used it. Start this code. Okay. Terminating, missing a character. It's here. This PDF is giving a lot of mistakes. My name is Omar. Last name is Kusa. And the birth month is 9. And here it's 29. And here it's 1004. So this is my information. Omar Kusa, birth date 9. Okay, that's the real one. Okay, enter the current month. It's 4. The current day, it's 19. Pretty sure it is. Current year is 20,023. Okay, so my age is 18. That's rounded. Maximum heart rates enter the current month. Okay. Current day. It's 19. And the current year. So it's 202 beats per minute. Enter the current month, day, and year. Now the target heart rate is from 100 to 127. It's pretty sure. I'm pretty sure this is right. It is right. It is standard. Let's get to the chapter 4. It's all easy. I'm pretty sure. You don't have to test them because they are easy. Write a triangle. So, side, right triangle. Okay, here is it. Write a program that reads 3 non-zero integers and determines and prints whether they could be the sides of a right triangle. It's pretty easy. It's just the Pythagoras or Pythagoras method. So we have the main here. We just enter 3 non-zero integers, side 1, side 2, and side 3. That's it. So in the header, we have a private side 1, side 2, side 3. And here in the public, we have two functions. One is Boolean. Is right triangle true or false? If it's not a right triangle. Here, right triangle, int S1, that's side 1, side 2, side 3. And that's the constructor. So here, we have to do with the CMAP. So we can use the power function. Right triangle, okay, right triangle, S1, S2, S3. Here we just get or set the triangles to the sides. And here is the real talk. Power, side 1 to the power of 2 plus side 1 to the power of 2. Side 1 to the power of 2 plus side 2 to the power of 2 must equal to side 3 to the power of 3 of 2, and that is the Pythagoras method. It's easy. Factorial. Okay, pretty sure we took the factorial a lot of times. We just go to the source. Here is it. Here is the factorial, just 1. And here is the work. So, if it's not 0, return 1. Else, return n. Let's say it's 5. It's gonna return n multiply 4. Because 5 minus 1 is 4. Okay. 4 is gonna return this. 4 is going to be 4 multiply 3. So 5 multiply 4 and 4 multiply 3. 3 is going to just enter it. So 5 multiply 4 multiply 3 multiply 2. And then it's going to be multiply 1. When it's multiply 1, return 1. Okay. It's going to return 1 here. Just right here. It's going to return 1. So it's going to return n multiply 3 multiply 4 multiply 4 multiply 3 multiply 2 and multiply 1, and it's gonna stop here, returns a 1. It's gonna stop the factorial thing, and it's gonna just return the 1 and stop to just not gonna return here. So when it's 1, this is gonna stop. The 5 4 3 2 1 is gonna stop and add up together. We will just use it here. Factorial if we made up an object and we just entered into the end result and we print it out. Okay. Oh, it's pretty easy. Here we have encrypted number. We just have to encrypt it and then decrypt it. So, that's good. I used the header this time. It's right. We use the namespace. Okay. So, int encrypted. We took the encrypted number. We just entered the get number inside it, and we just displayed the encrypted number. And here we're gonna use the decrypt. So the decrypted number is gonna just enter into the decrypted number, and here is I'm gonna just scan the number in the decrypted number, and it's just gonna give me the right answer. So I use just 3 functions: the get number that I use it here, the encrypt and the decrypt, and number. Let's see the source. So here is the method of the encrypt. I just take every digit alone, every digit alone, every digit alone, every digit alone. Here digit 3 is gonna be the first. I just switched here in the answer in the question. I'm sorry. He just asked for it. Here. Okay. So here, replace each digit with the result of adding 7 to the digit and getting the remainder for dividing it by 10. Then swap the first digit with the third and the second with the fourth. That's easy. Let's see. I just added 7 to the digit, and I took the remainder of 10 of it. I took the remainder 10 of it. I took the remainder, and I took the remainder. So we're just gonna end with 1 digit. Here I just added 7. I added 7. I added 7. I added 7. It's easy. I just switched the third with the first and the fourth with the second. Here with the decrypt, I just did this thing. I took the number. I took the first digit that must be the third. I just took it. I take the remainder of it from 10 and I minused it, subtracted it with 7. So if it's negative, I am just gonna add 10 to it, so it's gonna be converted to positive. Here, I just did the same. I also here did the same, and here I did the same. Here, I made the 3 that is here, the first one, that is the digit 1000. I just took it from it. And now 1 is the 1000, not 3. And here the fourth one, that is the 100, must be here. I just put it in the last and give it give the 2, that is the last digit. There is no division here. There is no division here. That means it was the last number. Now it's not the last number. Now it took the place of the fourth digit that is here. Okay, I finished with it. Multiples of 2 with an infinite loop. Oh, that's pretty easy. Let's go to the source. So, display power. Yeah, I just see out it. So while true, that is gonna be infinite loop. True, it's not gonna break. Where is the break? There is no break. So I just power it with 2. 2, 2, 2, 2, power 2, power 2, power 2. Endlessly. Okay, we don't have a answer for this question. Just gonna see it from here. Oh, I'm sorry. Okay, write a program that reads the radius of the circle, computes and prints the diameter, the circumference, and the area. So I just made 3 functions for it. Simple logic. Here the radius. Okay, I made an object double radius. I just made the radius database double because the radius is gonna have some 0 point things. It's gonna be okay. Here, enter the radius. I just scan it. I set the radius. I get the diameter, I get the circumference, and I get the area. So here I set the radius. Let's go right into there. Have a quick look here. Class circle. We have the set radius, get diameter, get circumference, and get area. Just set the radius. Okay, we have the radius double here in the private. Okay. Here is the real talk. Void circle set radius. Okay, so here I just set the radius that is here from the private to the rad that is just right here, and in the main this is gonna be it. I just took it. This is gonna be rad here, and it's gonna be set to radius from the private, and here get diameter. Okay, let's get the diameter. The diameter is pretty sure in maths returns 2 multiply the radius. The radius is a half, the diameter is the full one. It's just we're gonna have to multiply 2. Here get the circumference. I just multiplied pi with 2 and with the radius. Here I just have the power radius of 2, or radius multiply pi. Here the area. And I just printed them here. Printed the circumference, diameter, and the area here, here, and here. Chapter 5. Okay. Summing integers. So, here in the main, okay, made an object, sequence sum, okay. Oh, okay. I just enter the number of the values to be summed. So the first number is gonna set the numbers that are gonna be summed. That is sequence size. Okay, that's the first number is gonna set them into it. So when I just set it, then I'm gonna have a for loop, and it will end with the sequence size that I already determined it with the cn thing. So enter a number, he's gonna enter a number and just add it to the sum. Add number. Okay, he's gonna still add it and add it and add it. When he finish, he will just print the sum. And here in the header, let's just skip it with a quick look. And here in the source, let's go to the function. Here add number, sum, is gonna just be added to the number, and we will get sum. We're just gonna return the sum from the private here. Sequence size is gonna be entered into here. Sequence size is gonna be equal to the size. Yeah. I just used it in the main. Pythagorean triples. Oh, I just made a Pythagorean before this. Let's just enter too quickly. I'm getting tired. Okay. Pythagorean triples. Okay, that's just an object. Find triples. Yeah, I find every right triples of the Pythagorean algorithm or Pythagorean method. I am just gonna make a big for loop to take all the right Pythagoreans from 0 to 500. I'm pretty sure it was like that. I worked hard on it. Okay, so here for side 1 equals 1 to 500, and here to 500, and here to 500. Okay, see out side 1, side 2, side 3, and there is tabs between them. Okay, we just made an integers for them. You can just see here we have only one function, find triples. Okay, from 1 to 500, from 1 to 500, from 1 to 500. If the Pythagorean method, that's it. Hypotenuse multiply hypotenuse equals side 2 multiply side 2 plus side 1 multiply side 1. And then just, if yes, just print it. Print all of them. And if no, it's just gonna end and return to this one. Return to this one. It's gonna use all of from the 1 to 5 hypotheses. And when it finishes, it's just gonna go to the 4 and just gonna add just 1. And then it's gonna go all around from 1 to 500, just gonna add just 1. And when this loop finishes, this is just gonna add just 1. And the loop will gonna return forever like this. When we finish, and it's gonna be a long run, we just have all the right triangles in the world from 1 to 500. Bar chart, yeah, it's easy. Okay, I just made an object and I just used one function, print graphs. Let's see it. So we have here one function and one private number, integer, it's num. Okay, here, print graphs. So enter a number from 1 to 30, and I just entered it. And here, this method, this function is too smart and too easy. So if I enter here 5 times, I have five times tries to enter a new number every time. So every time I enter a number, this function right here that I took it from the std is gonna print these symbols, the amount of the number I choose. So if I choose 30, this character right here is gonna print 30 times. It's gonna print 30 times. This function have a for loop in it. Inside it, it's built in. It's pretty good. So I'm just gonna enter 5. It's gonna print 5 of these. That's a try. 30. That's a second try. 40. 25, 6, and 2. That's all the 5 tries. And this, it's gonna end. Okay. Product of the odd integers. Oh, that's easy. I have an object right here. We just use the product function here. Product of oh, am I recording? Yes. Product of odd integers from 1 to 15 is product. So here the product is gonna equal to the product that is gonna equal to the function. Let's go to the function right ahead to the source. Here, this is the function, and it's gonna return product. What is product? Here is product, and it's determined here. So product equal 1. So for this for loop, int I equals 1, I plus 2, not plus plus. Why is that? Because it's gonna jump to the odd numbers only. It's gonna be 1, it's gonna be 3, 5, 7. That's all the odd numbers without I make an F. It's a smart move. And here it's gonna end when it's gonna be 15. When it's gonna be right to equal 15, it's gonna end. And the product is every time is gonna multiply 1 with the 1. 1 with the 3, that's gonna be 3. 1 with the 3 with the 5. 3 with the 5 with the 7. 3 with the 5 with the 7 with the 9. It's gonna get a big number, and when it finishes, this big numbers is gonna be returned and go to the main to be printed. Average integers. Averaging integers. Okay. Include okay. I just use that object here. Okay, enter integers. Okay, enter 99 to stop. So for, oh my god, where does they go? Where did they go? That's not a for, that's a while loop with a true. I will edit it. While loop, and it breaks right here. This is a while loop inside it true. Okay, this is a while loop inside it true, and it will break when I say 99. It's gonna always take a number. It's gonna always take a number. Always take a number. But if it's this, it's gonna break. Okay, every time it goes here, it's gonna enter to the average calculator. It's gonna enter to the add number. So every time it's gonna add it. Every time it's gonna add it. Where is the add number? Where is this source? It's just right. Oh my god. Oh my god, where are they? Okay, I'm gonna edit it and send it full. Okay. This PDF, it's just ruining everything. Okay. Oh, chapter 6. Exponentations. Okay. I forgot what was it. Okay, here is it. Write a function, integer base exponent that returns value of integers assuming is a positive non-zero. Do not use math library. Yeah, it's easy. It's pretty easy and fast. Okay, here is the base, here is the exponent, integers. So enter the base, enter the exponent. Yeah, I just cn. And here the result is calculate base exponent. From where did I bring those? I just bring them from the integer powers that are here in the class public. There is just only the static int calculate. Okay, it's int base and int exponent. So where we gonna use this in the for loop? It's just right here. Okay, int integer power. So this for loop, it's gonna just result equal 1, start, 4, int I equals 0, I to the exponent, I plus plus, it's just gonna multiply the base with it, multiply the base, multiply the base, multiply the base. Why did I start it with 1? Because the first time I multiply it with the base, it's gonna turn, like if the base is 4, it's gonna turn from 1 to 4. And if the base is 0, so it's gonna stop, and the exponent of the 0 is already 1. So I don't have to make an if here. It's pretty smart. Return result. I return the result and print it in the main. What? Oh my god. This is driving me crazy. Okay. Hypotenuse calculations. So here is the IO stream. I'm pretty sure the word is not that bad. It's this one. Okay. Oh, I should have thought about this long time ago. Oh, just look at that. Yeah, it's pretty close to each other's. But that PDF, oh my god. Yeah, yeah. Let's just return to the one that I said I will edit it. So I make sure I don't forget it. I'm sorry. Here is it. Power of 2. No, it's not here. It was just right here. Yes, yes. Just right here. Okay. I'm sorry. I'm just have to go to it because I am not gonna make another 1 hour video for it. Okay. Just a second. Ready to go. Where did it go? Sure, it was here. Here is it. Before the chapter 6. Let's go before the chapter 6. Here is it. Okay. So add the number. Okay. Okay, I'm gonna just edit it. Let's go here. Let's return again. Sorry for the interruption. Okay. Include IO stream int main hypotenuse double A B C. Yeah, that's the Pythagoras. Pythagoras another time. Enter length of side A, I entered. Enter B, I entered. C equals hypotenuse calculate A, B. So where is the hypotenuse calculate? I'm just gonna put it in C. I'm just gonna print the C. The C is this function, and this function is gonna have A and B that I just entered. Let's go right ahead to the function. Here is it. So double C, I just made a new double, is square root of power A to 2 and power B to 2. We got the hypotenuse. We just got the hypotenuse and we return C, and the C just get into the C and the C is printed. Easy. Okay. Square of, oh, this is easy also. Here is display square. Okay, that's an object. You just use this function. What is this function? Let's go see. It's only this one. And here is it. Display square. So inside, I just made a side. Enter the size of the square. I just entered a number inside the side. And then I just made this this character go along from 0 to the side and another time from 0 to the side, and every time it's finished with this one, it's gonna make a new column here. It's gonna make a new column with the end line. That's a new column. Again to the side, a new column. Again to the side, new column. Again to the side, new column. And this will make a square. Side multiply side. Even numbers. Even E. And then I made an integer num. Series. Enter -1 to stop. That's a while loop. Pretty sure. So I used the do while loop. And I entered the number that I just initialized here. Okay, so if the number is not equal to -1, that is the stop mark. If it's even, that's the function that checks if the number inside it is even. It's gonna be true. That means it's gonna just type the number and say it's even. Else it's not even, it's odd. Okay, and that's it. While number -1. So let's go straight to the function. This is a bool, yes, it's a boolean. In here. So if the even number just have a remainder 0 by dividing it by 2, it means that it's even and it's true. Yes, it's even. Okay. Reverse digits. Oh, okay. I'm pretty sure it's the last one. Okay. Reverse, we just made an object here, int number. I made a new integer. I called it number. And here I have the cout enter number. So cn, I just put a value in this integer num, and this value is gonna be reversed. So reverse is gonna enter to this function, and the number is gonna enter into this function, and it's gonna be just printed out this one. So let's go ahead to this function and see what is gonna do with the num. So here is it. It's an int, and it has a one int. Okay. So it just took the int, the num, as it is, and it made a new integer called reverse. It's 0 now. And while num not equal to 0, so if I didn't use a 0, if I didn't just put here a 0, because the 0 can't be reversed, it's not 0, int digit. It's just gonna take the remainder, the last digit, and reversed reverse multiply 10 plus the digit. So the digit here is the last digit, and the reversed here is the 10 plus the last digit. It's gonna be just from 9 to 1. So we're gonna have reversed that is equal to 0, equal 0 multiply 10. That's gonna be 0 plus the digit. So we have the first digit, the last digit here is the first digit here, and then we're gonna divide this by 10. So the digit we took is gonna be deleted, and we're gonna take another new digit. We took another new digit. Okay, we took another new digit, and the last digit that is here is multiplied by 10. So it opened a new space to put the new digit. We took it here. That's a reverse. And it's just gonna be stored in the reversed one. And it's gonna open a new digit, and this new digit is gonna be this third new is gonna be the third last. And it's gonna be the fourth new is gonna be the fourth last. fifth new is going to be the fifth last, and in this way the integer we entered will be completely reversed. Thank you for watching. Hope you a nice day and hope the voice is clear.